Hello everybody, my name is Jagati Pramadipatla, and today I'll be presenting to you the SigningSequencer, which is my project for WAICY. So what is the SigningSequencer and what problem is it currently trying to solve? Well, there are currently 600,000 members in America who are part of the deaf community, and only 250,000 Americans know ASL, and these are members who aren't deaf. So this poses a major issue for members of the deaf community and members of general society because of this learning curve. 600,000 people, while it might be a minority, it's still quite a large number because many of these deaf people live in large areas, which just increases human interaction. And with no real viable form of interaction and communication between the deaf community and general society, we introduce a whole new set of problems. There's currently no really feasible way to convert ASL to text other than a translator, and this can get quite expensive. So what is a SigningSequencer and how does it help? So basically, the SigningSequencer is a set of algorithms which detects and recognizes ASL, which is American Sign Language letters. And American Sign Language letters are pretty much the same as the English alphabet, A through Z. And this algorithm works in videos, images, and real time for flexibility. As you can see, we have a snapshot right here of a little bit of our code. And you can see that the computer accurately identified the letter A in sign language. And this is an image for presentation purposes, but as I said, it works in videos and real time. And the implementation of this algorithm is set to be on a website for easy accessibility. And we created this through a set of hard cascades for image recognition written in Python and OpenCV. So how is it made? The algorithm itself was trained for each of the 26 letters of the English alphabet. And as I said, this is the same for ASL. And we used OpenCV model 3.4.11 to get the terminal commands for creating hard cascades. And as you can see, we have a folder in theory, for each of the letters of the alphabet. And in each of these folders, we have 3,000 pictures of that letter in sign language. And these are taken in different lighting conditions, different skin tones, and different sizes, and things like that, to train the model more accurately. We also included another 3,000 negatives, because the way a hard cascade works is it trains itself based on the positives, and a positive is basically whatever you're trying to detect, and it references those against negatives, which is anything but a positive. So by including such a large data set, we'll only increase the accuracy of our model. Now, how does the SigningSequencer work? Well, let me show you. This is in its raw form, not in a website, just for presentation purposes. So over here, you can see that we have various files, each containing thousands of different pictures of every letter of the alphabet. So when in theory, what's going to happen is this code over here, it's going to take into account a cascade file. Over here is going to take into account a .xml file that we created. And it's going to put an image that we select into that file, and it's going to detect any images if it does see any. So let's go over here to our project. So, okay, let's pick the letter A, for example. And let's pick an image really far down. I don't know, yeah, sure. So let's copy this image and put it out here. So you see the image name is A1123. And again, this is just for presentation purposes, just to show you that the code does indeed work. A1123. And now, let's run it. As you can see, the code does interpret and finds out what the letter A is in sign language. So this is the actual code running in person, and these are the dimensions of the boxes and everything like that. So when we go back over here, you can see some of our .xml files in. You can see some of our .xml files in this folder cascade, and you can see this is just for the letter A, and you can see the training stages for each one. And as the training stages increase, the number of false positives and the accuracy, the number of false positive decreases, and the amount of accuracy increases. And this is further helped by how much your data set is. And we have around 1,000 to 3,000 pictures for each image. So our model is actually pretty accurate.